Hi, and welcome everybody for our lunchtime conversation with Vermont Coverts, Woodlands for Wildlife. Today we're hosting Jens Hilke, who's a conservation planning biologist with the Vermont Fish and Wildlife Department. And he's going to be talking to us about Vermont conservation design and where we fit into this concept of a connected landscape across Vermont. Jens, I'm going to turn it over to you. Again, before he starts, just remember, keep your microphones on mute, type any questions in the chat box, and we'll relay those at the end. Thank you.
Good afternoon, everybody. A real pleasure to be with you. I see some familiar names on the list. Great to see you and great to meet new folks. This afternoon, I'd like to talk about understanding where you fit in and really thinking about connectivity and the Vermont conservation design. So, I got into this business because I like tromping around in the woods and the wetlands and exploring wonderful places. And I'm sure that rings true for many of you all. And it's place. That's the hook. That's where the love is. That's where the connection is in terms of relating to the natural world and that desire to learn more about it. What I want to start there today, but I want to bring that and think about parts of the landscape that we might get a little bit more meaning from by understanding a larger context than simply what we can experience in the field. So a few, I guess, months ago now, a group from Huntington asked me to come out and look at the Heinsberg Hollow Road. This is the Huntington Conservation Commission. And they're really interested in this stretch of road. There are thousands of salamanders that cross the Heinsberg Hollow every year. And the Conservation Commission was just really interested in this piece of road, really interested in that wildlife migration, and not just the salamanders, but a variety of other species used that section of road to cross. And when you look just at the aerial photo, zooming out from what we experienced in the field, just looking at that aerial photo, it really does make some sense. You can see the uplands with the evergreen trees and the darker color and the deciduous trees. And then down closer to the road, you can see the wetlands on both sides along a long stretch of Heinsberg Hollow Road. So that got me thinking, like, well, let's zoom out a little bit. Let's learn a little bit more about this context. And sure, walking the road, I saw things on both sides that got me excited, that got me thinking about why that might be an important area. But I want to zoom out a little bit more and understand this place from a slightly larger perspective. So I went on BioFinder, and that's BioFinder. You can just Google BioFinder or go on biofinder.vermont.gov. And so I zoomed into this same section of Heinsberg Hollow Road and started to just poke around. And when you just click on a place on the map on BioFinder when you first load it, it tells you what's present there. And so for this particular spot where I clicked, it shows up as the highest priority riparian connectivity area. And then I clicked around some more and I found some other things. And so it starts with this landscape scale perspective, things that you maybe can experience on the ground, but you can also get this much larger context. So then I turned on what we call the species and community scale components up there in the top left. And I kept poking around and learning more about what's on BioFinder. And here, I clicked right beside those wetlands and no surprise, those are highest priority wetlands. And so I kept on exploring this species and community scale and found a variety of significant natural communities, several different wetlands. It's all one wetland complex. And then lo and behold, a wildlife road crossing. Now in BioFinder, you can see the overall priorities like we're looking at right now. And those include the species and scale and the landscape scale. I'll explain this in a different way a little later in the presentation. But so you can poke around like this and look at all the components together and look at that overall prioritization. Or you can turn that all off and really go one by one. And so here we can see that Heinsberg Hollow Road shows up as a highest priority wildlife road crossing. Now, the way this model was created, it isn't actually because of the amphibians that cross here. We have a lot more work to do in terms of modeling amphibian road crossings and figuring out those so-called squish zones. But wildlife road crossings is an important part of understanding your place and beginning to zoom out and see that larger context. So what am I talking about here? Well, wildlife road crossings are often evergreen and wetland cover, where vegetation is close to the road on both sides, and they connect these larger forest blocks. In Vermont, the system of wildlife road crossings is very spread out. There are hundreds of crossings, as you all well know, across Vermont where animals are crossing. And Lisa and I were talking a little bit before the presentation about wanting to go to Banff and see some of these giant wildlife overpasses. Well, that's really appropriate out west, where they have species of ungulates, the pronghorn antelope, where thousands of them are crossing over the road at the same time of year, and they're, it's a real risk to the animals and the driving public. In Vermont, we have more of a spread out system. And so you're more likely to encounter the solitary moose, like we're seeing here at Shutesville on Route 100. You're more likely to encounter that solitary moose than you are some sort of massive migration, aside from amphibians. And so the network of wildlife road crossings is actually pretty sophisticated or pretty complicated. So in this most recent version of the Vermont Conservation Design, that's the science behind the BioFinder website, we updated this wildlife road crossings data set. And so at left is a map from Georgia, and the green are just habitat blocks. They're forest blocks. I'll explain those in more detail in a bit as well. So that's not about land cover, that's not about land ownership, it's only about land cover. And then we split up the road sections into plots on both sides of the road. And we measured, this is all by computer, this is a model, we measured the percent cover of the forest block within those plots on both sides of the road. And so you can see the forest blocks at left, you can see the aerial photo at right, and it really makes sense. You can see those places where the forest is close to the road, you get a lot of blue on both sides of the road. And where there are a lot of fields on both sides of the road, you don't. And so then places that have more than 75% forest cover on both sides of the road get flagged as the highest priority for wildlife connectivity, as a wildlife road crossing. 50% would be priority. Now that potential wildlife road crossing piece is interesting, and I see there's somebody on from Cornwall. And Andrea, I'll just add, those potential wildlife road crossings are really helpful in that more the agriculturally dominated part of Vermont. And so those potential wildlife road crossings can flag areas where wildlife crossing is possible. But for most of Vermont, the highest priority and priority are really the way to look. And so here you can see, I'm just advancing on the right there. And so here you can see how sections of Georgia where there were in fact trees and wetlands on both sides of the road get flagged as highest priority, that darkest purple. And places that are priority get flagged as that lighter purple. And so you can see how we've gone from the percentage of trees on both sides of the road to understanding which segments of road are most likely for road crossing. Here's some bobcat GPS data, telemetry data from Route 116 around Shelburne Pond. And you can see where this cat spent a lot of his time. In the wetland itself, that brownish color is wetland. And in the summer, that's a great place for a cat to hide and hunt. You can see that the cat is spending a lot of time in the forest on both sides of that wetland and on the edges of the field, but not in the middle. Now look at this. For that cat, it was significant just to have a tree line, a hedgerow that comes up to both sides of Route 116 to make the connection between this good quality habitat in the wetland and the foothills of the Green Mountains there on the right side of the picture. So animals are moving around to get what they need. They're using different habitats at different times of the year for different food sources. And so species that move around, or species that have that need different food sources, are moving around to meet those daily needs. Now, sometimes there's a bad mast year, and here we're looking at black bear telemetry data, a male bear that was collared and was roaming around in October of 2017, was right near Bennington. And in response to low food availability, this bear just up and moved and did a 140-kilometer journey from Bennington to Brattleboro and back. So some of the movement is on a really much bigger scale than you might suspect. So we're beginning at the parcel. We're beginning by understanding one particular road segment, one particular place that we love. And then we're beginning to see, well, wildlife are interacting with that place on a much different scale. Now, just as an aside, and I hope you can see the bear down on the bottom left of this photo, this is a big culvert under Route 17 in Starksboro. And so I just wanted to take an aside and mention that this also brings us to thinking about transportation infrastructure. And so we're talking about green infrastructure, right? The forests, the wetlands, where those big blocks of habitat are. We're also talking about gray infrastructure, the culverts, the bridges, the opportunities to get under the road as well as over the road. And so these sorts of structures can be incredibly important for wildlife road crossing. And so there's a lot to say here, and I don't want to get off topic, but I just, as we think about flood resiliency and appropriately sizing our infrastructure to allow for passage of floodwaters and debris and so forth, well, we're also allowing for wildlife movement under the road. And so again, this diverse network of wildlife crossings throughout the state really benefit from having appropriately sized infrastructure where there's a lot of light, and species like bear will really happily go underneath the road. So I've been talking about these species that have big home ranges, that are using multiple food sources to get what they need, different foods at different times of the year. Well, bobcat in the Champlain Valley have a home range. The males have a home range on average about 27 square miles. The males are moving about 19 miles per day. Black bear have a home range of about 20,000 acres each, and moose are somewhere between 1,200 and 12,000 acres. River otter are using 15 to 30 linear stream miles. So they have really big home ranges, and they're moving around to get different food sources at different times of the year. So again, I'm beginning to zoom out, and I'm starting with those wildlife road crossings and a particular place on the map that we love. And now we're beginning to piece together that from a wildlife perspective, that network is much bigger than that one particular place. So this brings us to this concept of a forest block. I mentioned these before, and I just want to take a moment to ensure we're on the same page. We're talking about areas of natural cover surrounded by roads, development, and agriculture. This is not about ownership. This is just about land cover. Forest blocks in Vermont range in size from 20 acres, that's where we cut them off, to 150,000 acres. You can see in the map at left, those are colored by size. The largest forest blocks in Vermont are along the spine of the Greens in the Northeast Kingdom, and a few splattered along the Piedmont. And so these forest blocks are really a critical element in our planning. And so again, as we think about scaling up from an individual place to wildlife road crossings to the actual habitat that wildlife need, well, using these forest blocks as a unit to understand wildlife habitat and wildlife movement is really helpful. Now, in the most recent version of Vermont Conservation Design that we just updated in 2023, again, that's the science on the BioFinder website, we dramatically improved these forest blocks. We moved from a 30-meter pixel. So we divided the whole state up into a grid of 30 meters by 30 meters and decided which, what blocks, which of those pixels was considered forest. Well, we moved from a 30-meter pixel to a 0.5 meter pixel. So we increased the resolution by 3,600 times since the previous version of our Habitat Blocks dataset. So this leads to a much better, this better resolution leads to a better understanding of wildlife road crossing and a better understanding of the edges of the blocks. We did not learn about any forests that we didn't know about before. So this is really about clarifying our understanding of the limits, the edges of the blocks. So you can see an example here on screen from Waitsfield, the aerial photos at the top. The 2011 version of the Habitat Blocks is at the left. The 2023 version is at the right. And so you can see how blocky the older version is and how much more crisp it is in the 2023. Now, we removed a 150-foot buffer around each house, each building in Vermont. And so you can also get a sense of where forest blocks take on a bit of a Swiss cheese appearance because of development. So there's a really intuitive display of where there's been some degradation in the quality of the habitat block because of development. And again, we get a much better understanding of wildlife road crossings. You can really see how by having a better understanding of the edge of the block, we're able to understand better how that block interacts with the roads. And so you can see how the wildlife road crossing here in Waitsfield really shows up on the map in a way that it didn't in the previous version. So we're beginning to build, and now we're talking about forests and forest block as habitat, but really as a home for a lot of different community, economic, and ecological values. Larger forest blocks are more important for biological diversity. They're important for scenery, for clean air and water. They provide land for working forests and the revenue that comes with that, the economic benefits of recreation and tourism. They prevent erosion and reduce flooding. That's saving us millions of dollars each year. They provide land for hunting, fishing, and wildlife viewing. That's $685 million to the Vermont economy each year. Did you know that larger forest blocks transmit fewer tick-borne illnesses? They're more intact. There's less edge. There's less tick-borne illness. And of course, these larger forest blocks sequester carbon and absorb harmful gases. So these forests are saving us millions of dollars each year. They're contributing to our economy. They're contributing to human health, and they're contributing to our ecology and providing habitat for species that are moving around. So when I work with towns, I talk about this image quite a bit. And so here's an aerial photo from Rutland County. And so here's the pattern that we're looking for. First, we want to identify those largest forest blocks, the core forest, the biggest ones in each town. And those are the anchors of the whole system. But if you think about it, wildlife can't actually get from the big block at left to the big block at right without using this block in the middle. So some of our forest blocks, even though they might be smaller, are incredibly important because of their landscape context, their position in the larger landscape. This is something you can't just intuit by being on the ground and looking at that road crossing. But here are those micro connectors, those wildlife road crossings, and the entire stream side. And so in the Champlain Valley, that riparian, that streamside vegetation, that riparian network is incredibly important for knitting together the forest blocks. And across all of Vermont, these wildlife road crossings are knitting together this forest block. So this is the larger pattern we're looking to maintain in our towns. The Nature Conservancy estimates that entire populations are moving north and south away from the equator on average 11 miles per decade. That's about a mile per year. I'm not talking about individuals, I'm talking about entire populations moving north and south away from the equator, a mile a year and about 36 feet up in elevation every year in response to a changing climate. And so maintaining this pattern of connected forest is critically important for allowing animals and plants to move in response to climate change. These are the pathways where plant and animal movement happens. This is how we allow for that movement. This is how we adapt to climate change. So these habitat connectors, the forest, the stepping stone forest block in the middle, the wildlife road crossings, the riparian network, are critically important for thinking about this larger pattern. So let's keep building this larger pattern. I'll go back to Heinsberg Hollow Road. You see that blue dot, that's where we were before. And now I'm beginning to zoom out a little bit more. And I'm looking at one component of the overall design that's in Biofinder. And that one is called connectivity blocks. And so these are the forests in Vermont, and I'll explain this again later, but these are the forests in Vermont that allow for animals to move from the Berkshires up to the Suttons in Quebec, from the Adirondacks over to the White Mountains and the Blue Mountains of Maine. These are connected forests. And so here at Heinsberg Hollow Road, we can see that both of those forest blocks are considered priority. So what do we do with that? Right? They're not highest priority, but I think the context here is important. So priority means, I'll start with this. Highest priority is the backbone of connectivity. We know beyond a shadow of a doubt that those forests are absolutely important to serve as this network of connected habitat. Priority blocks we know are playing a supporting role in this larger network. And so let's zoom out a little bit, and you can begin to understand how these priority blocks are participating, are supporting this backbone of connectivity. Let me just zoom out one more time, and I think we'll see it even more clearly. And so you can see that main spine of the greens, north and south, and you can see how the priority blocks on both sides of that are playing a supporting role, are buffering that backbone of connectivity. So what we're talking about here is regional connectivity. We're talking about highways of wildlife movement, right? This ridgeline, the spine of the greens as this backbone of connectivity, with the understanding that not only are there these highways, but they're also the byways of wildlife movement, that the actual network of connectivity involves all manner of local roads. It's much, much more complicated than this series of arrows on screen, but this is the foundation of it all, these connected forests across the state. That's what's allowing for climate resilience. That's what's allowing for wildlife movement, both these huge migrations and also that day-to-day movement between, or year to year, week to week, whatever it is, between blocks. So we can think about movement and connectivity not only at that local scale of the wildlife road crossing, but at this entire statewide scale of connected forests. And then we can zoom out even more and think about this across the entire northern Appalachian Acadian ecoregion. This is the focus of the Staying Connected initiative, a public-private partnership focused on habitat connectivity across this binational area. And so you can really see how Vermont is the crossroads of connectivity across this whole area, and how many of those eco-regionally significant linkage areas are present in Vermont. Okay, so far, we started with a particular place, Heinsberg Hollow Road. We zoomed out and we started thinking about habitat on both sides of the road. And then we started thinking about wildlife movement on an even bigger scale between habitat blocks, and then wildlife movement across the whole state, and now wildlife movement across the entire northern Appalachians. So I've been trying to give you a sense of how you can use BioFinder to get context for a particular place that you love, how you can zoom out and begin to see that place in a much bigger context. Now, I'm just trying to give you more reasons to love the place you do, the places you do, right? I'm trying to add value and add context to what you're exploring on the ground in your backyard and in places across your. So let's just think about this a little differently now. I want to get into talking about the conservation design. And so I've been showing you screenshots from the BioFinder website. And that's how you can gain, BioFinder is the tool for gaining this larger understanding. But let's talk more about the science behind that. So Vermont Conservation Design, that's the science that's hosted on BioFinder. And it's a science-based vision to sustain the state's valued natural areas, forests, waters, wildlife, and plants for future generations. Okay, so it's a design. It's a big picture vision. It answers how much is enough? How much forest do we need? Where are those most important forests? What are the different values of those forests? From anchor blocks, interior forest, to connectivity blocks, to thinking about the entire riparian stream side vegetation, the entire riparian network. So the design it works in several different ways. So I just talked about it as a prioritization, right? It identifies the ecologically most important lands and waters. It also helps maintain nature and the benefits that it provides. And it's our conservation framework. So in this next part of the talk today, I want to think about the design in each of these ways and add a little bit more understanding to each of those pieces. So at the landscape scale, it's a prioritization. And it includes, so you can think about VCD as a singular map, right? This map, the ecologically functional landscape. And these are the places in Vermont that are most important to maintain for ecological function. And that includes those highest priority landscape blocks, selections of those forest blocks, that concept that I explained earlier, the entire surface water and riparian area network, and these hotspots of conservation, things like highest priority natural communities or habitat features like rare, threatened, and endangered species. So together, this is that ecologically functional landscape. And we want to keep it as intact, connected, and diverse. Now, this is a lot of land area. And so what we're talking about here isn't a no touch, thou shalt not develop anywhere in this green. That's not what we're talking about. These are the lands and waters that we need, where we need to maintain ecological function. So we start with this big prioritization of what's most important. And then we're going to drill in to figure out, well, what are the components at that spot? And hence, what are the ecological functions? What's the job of that particular spot? Whether we're talking about wetlands and cleaning, improving water quality, whether we're talking about interior forest as home for biological diversity, different spots have different jobs, ecologically speaking, different ecological functions. And so we want to start with this big picture prioritization, and then we want to understand, well, what are the functions that are present that a particular job is doing? The ecological functions of a particular spot. And then we can begin to understand, well, what are the human uses that might work well with that function? So if we're talking about interior forest, right, the largest forest blocks in each ecoregion, well, you can certainly put some housing around the edges of that forest block and not impact its job as being interior forest, the deep, dark woods. However, if you put those houses on the part of the edge where there's a wildlife road crossing, well, yes, you can absolutely impact that function of connectivity between the blocks if you put a house right in the middle of the wildlife road crossing. Or, develop the floodplain. What's the ecological function of the floodplain? Well, it's about water quality and allowing for river process and allowing for floodwaters to be stored and then disperse. And so, housing, in my opinion, is not a good call for being in the floodplain. I think Vermont has learned that language again, that lesson again and again. So my point here is we want to start with this design, but it's not a go, no-go scenario. We need to then figure out what the functions are so we can begin to understand what human uses are appropriate there. I'll just go back to this map of Heinsberg Road and say, this is that landscape scale prioritization. And this is showing us the highest priority and the priority areas. But then we're going to drill down and we're going to explore what those ecological functions are, what the different jobs are. Now, in the conservation design, the language for that are landscape scale components. I talked about core forest, and there I'm talking about interior forest. I talked about connectivity, and there we're talking about these connecting forests, the connectivity blocks. There's also a prioritization of habitat blocks for geological diversity, making sure that all the ecological, the physical settings, the landscape settings are in place. And then, of course, this entire surface water and riparian area network. So let's just get into a little bit more detail about each of these components. Again, I'm trying to take that dark green, light green map of the overall prioritization. I'm trying to explode it into its component parts so we can understand what the functions are and begin to get a better understanding of what we're seeing at a particular place. So, interior forests. These are the largest habitat blocks in each region of the state that provide the best interior forest conditions. So I'm talking about deep, dark woods. Bigger forest blocks have more biological diversity than smaller blocks. Now, this gets complicated in Vermont because the Champlain Valley, the Connecticut River Valley, they actually have much, much more biological diversity than the spine of the Green Mountains. So we can't just look at the biggest forest blocks in Vermont. We look at the biggest forest blocks for each region of the state. So here's the map. And so you can see that we used a larger threshold for blocks along the spine of the Green Mountains, a smaller threshold for blocks in the Champlain Valley and in the Piedmont and in the Valley of Vermont. So, but regardless, for each region, these are the largest forest blocks. Now, also look at this map. So this gets at size. It also gets at core forest. So we set a core forest threshold. And so we wanted to weed out the blocks that had an irregular shape, like the long and skinny, because they don't have as much core. And so they're not as intact. So we use both acreage and core forest to come up with this selection of forest blocks. So again, I introduced habitat blocks at the beginning. There are like 4,052 of them in Vermont, between 20 acres and 150,000 acres. Interior forest blocks are one selection of those. There's something like 900 of them that were selected as highest priority and priority for interior forest conditions. Okay, let's look at another selection, another function here. And I had introduced this concept of connectivity blocks, and these are the network of habitat blocks that were selected to promote landscape connectivity across all of Vermont. And so we've seen aerial photos like this of understanding how the blocks are connected to one another, where those wildlife road crossings are. And then we've seen this network before, and just contrast this with interior forests, right? These include all of those largest anchor blocks, but this network also includes a bunch of stepping stone blocks. So this, when you see the orange here, it is continuous from north to south, from east to west. That was not true of interior forest when we just looked at size. So again, this is a different ecological function, and this is a different selection of forest blocks. Now, geological diversity, this is a different selection of habitat blocks that represent the full range of physical landscape settings across Vermont. So I'm talking about bedrock geology. I'm talking about slope, aspect. I'm talking about physical settings. Now, this is the stage for biological diversity. The stage, the actors move around on the stage, but the stage stands still. And so where there's diversity in the geological landscape, there is also biological diversity. And that's true now, and it's true into the future. So thinking about geological diversity is how we get to climate resilience. Places of diversity in the physical landscape are going to be biologically diverse in the future, even as the species change, even as those actors move around on the stage. And so geological diversity is how we can understand climate resilience. And so, yes, we can understand a particular bedrock type when we visit a particular spot. But understanding the geological diversity statewide, you really need to zoom out, understand that larger pattern and how a particular place maybe contributes to these physical landscape settings across Vermont. Also in the conservation design are surface waters and riparian areas. This is the complete network of lakes, ponds, rivers, and streams and their vegetated margins. This is everything that is wet. All of it is considered, for the first cut, all of it's considered highest priority. And so we want to convey that basic understanding that things that are near lakes, ponds, rivers, and streams, well, they're important for biological diversity. They're important for climate resilience. They're important for other functions like water quality and flood protection. So anything that's wet is really serving is performing an ecological function. Now, within the conservation design, that's the first look, right? That's the landscape scale. And you can also drill down and look at, well, what are those parts of the landscape that parts of the surface water network that are currently vegetated? And so not just being near water, but being near water and have trees on them. And so to that, we look for this riparian connectivity data set component of the conservation design. And so you can see at left the difference between the highest priority surface areas and that vegetated part, the riparian connectivity. Again, in 2023, we use this much finer data scale, resolution data to improve our forest blocks. This also dramatically improved the riparian connectivity data set. And so in this last version of the conservation design, our resolution for connectivity, riparian and forest blocks has really improved dramatically. Okay. So far, I've gone through those landscape scale components in the conservation design. So remember, that was the dark green and the light green. So when you put all of those highest priority areas together, they show up as dark green on the landscape scale prioritization. But you can also explode them in the component parts and look just at interior forest or just at riparian connectivity. So I'm trying to give you an understanding of how BioFinder is built, how you can understand it in its full context, the overall landscape scale, and how you can begin to blow it up, right, to see it component parts. Now, when we first started looking at Heinsberg Hollow Road, we were actually looking at wetlands and wildlife road crossings. Now, in the BioFinder context, these are considered community and species scale components. Now, there are a lot of these, and I often think of these as hotspots of biological diversity. So there's that landscape scale network, right? That's the big picture pattern that we're looking to maintain across the whole state. That's the big context. Now let's add hotspots. And some of these hotspots are going to add value to parts of that network. Some of these hotspots are outside of that landscape scale network. Let me give you a sense of what I'm talking about here. Things like natural communities, young and old forests, aquatic habitats, that's a prioritization within the surface water area, vernal pools, wetlands, wildlife road crossings, grasslands, shrublands, underground habitat, caves and mines, and of course, rare, threatened, and endangered species. So we can begin, if we begin at that landscape scale, we can begin to drill down into that species and community scale components and understand parts of the network that have value. In our case, we really started here, we zoomed out, and now we're zooming back in, right? And that's what I love about BioFinder and thinking at these different scales is being able to start at that site scale and then zoom way out and see that larger ecological context, and then zoom back in and see the hotspots in a different context. So let's just talk about one of these community and species scale components, and natural communities. And I hope you all are familiar with the book Wetland, Woodland, Wildland that really explains that concept of natural communities and names them. But for those who aren't familiar, these are interacting assemblages of organisms, their physical environment, and the natural processes that affect them. So they're often named for species that are dominant in that region. And here we're looking at a shagbark hickory, mesic maple, ash hickory oak forest on Snake Mountain. And then we can see the distribution of these significant natural communities across the state. So I'm just giving you one example of a species and community scale component where you can experience it on the ground. You can see how it's mapped across the state, and then you can see how that one community is one among many in a particular habitat. So when we think about BioFinder, we're thinking about the cosmic zoom. We can start at this landscape scale. We can see these overall prioritizations at this multi-town scale. Then we can begin to zoom in and see it at the town scale. What are the priorities, the highest priority areas, the priority areas across a particular town? Well, then we can zoom in even more and see those species and community scale components. What are they? Where are they? What's the prioritization? And then we can zoom into the parcel scale and understand how our piece fits in to this much bigger pattern. And I'm hoping that I've helped you understand how BioFinder can be used to better understand these places that you love, to do that cosmic zoom of beginning at the place and zooming out and zooming back in, to add more context, to add more value, to give you another reason to love the places that you love. All right. Wanted to allow plenty of time for questions and answers. So thank you so much for joining me today. I really very much appreciate your sticking with me. I'm going to stop sharing my screen and hear what kind of questions we've got.
Okay, Jens, we have one in the chat, and it says, what are the sources of species inventories for the BioFinder map?
So we, for rare, threatened, and endangered species, we're using the Heritage database. And so that's the Heritage program for the Vermont Fish and Wildlife tracks all rare, threatened, endangered species and uncommon species statewide. And so that data goes into the rare, threatened, and endangered species components of BioFinder. So that's one inventory of what's rare, threatened, and endangered. I'm wondering if you're actually asking, so that's one component, but species inventory doesn't inform the landscape scale work. That's done just based by land cover. The components like interior forest and connectivity blocks, those are selections of the forest blocks, those areas of natural cover. And so that's done just looking at land cover and figuring out where there's different types of forests, wetlands, shrublands, and aquatic areas.
So the question is, does the Heritage Program draw at all from verified iNaturalist observations or from form submissions only?
So iNaturalist is great, but it's point data. And iNaturalist speaks more to where a particular person has gotten excited about reporting something. And that's awesome. Don't get me wrong, but it's not statewide systematic inventory. And so I'm all about the crowdsourcing of information. I do think that has a role, but it's not appropriate for a statewide data set. So the Heritage Program absolutely uses field observations from certified consultants, but does not use iNaturalist data.
Great, thank you. Keep those questions coming in. Jens, I'm going to ask a question. I've been involved with review of some of these in the 2023, and it's, every time I listen, I learn something new, and I'm still not sure I completely get it. So that's why I love that this is recorded. And just, I love the cosmic zoom idea. And so if I'm on my town board or, conservation commission or something like that, what is the best way for me to bring this data forward to the town who may not be exposed to this, to share this information as we look at our town plan?
Yeah. Well, I think a lot of that work begins with the Conservation Commission and wrestling with what these data sets mean and what that pattern looks like. And so, I see a variety of folks on the call that are members of conservation commissions in Cornwall and Jericho and elsewhere. And so the Conservation Commission is really the first step. And but then there's also local inventory. And so bringing in field-based inventory is the next appropriate step for a Conservation Commission. And then bringing those together to say, okay, well, what does that mean for our town plan? How, if we have a better understanding of ecological importance, how can we marry that with community values for thinking about the future landscape of our town? And so that's when the focus sort of shifts to the Planning Commission and the Conservation Commission advising the Planning Commission on what parts of the town are most important ecologically, what that most important ecological pattern is. But all of this is really, education and outreach across the whole town is important at each of those steps. So it can't just stay with the Conservation Commission and the Planning Commission. The town-wide, everybody can play a role in helping all townspeople to better understand these data. And, I think of that as celebrating what we've got and not the dry kind of, let's review the data, but let's have a party. Let's go hike. Let's go explore these places and show our townspeople why they're so important and what there is to love about living in your town. And the more that all of us can celebrate these places in our town, the more value we'll see that they have. And then the easier it'll be to think about maintaining those into the future.
Let me ask you another question. In using it for, I don't know why there's an echo. In using it for like the DRB or something, can I cite, if I buy a piece, I bought 100 acres, let's just say, but there's no house on it, I want to build a house. Can this help inform where I site my house, or help the DRB inform where, a house might be best on a property?
Absolutely. This is actionable information. And so, the DRB can absolutely use it. DRB is tricky because they're just interpreting the rules that exist. So it's really at the planning commission level where they should be writing regulations that cite these data and hold together. And then the DRB interprets what the planning commission has created. But yes, this is absolutely actionable information for a planning commission to use in its town plan and regulatory work. I will say, it's a statewide prioritization. And so we zoomed into Huntington, and those blocks just showed up as priority. And in that statewide context, I totally understand it. They don't show up as important as those massive habitat blocks in the Northeast Kingdom. But in the context of Huntington, maybe those are highest priority. Maybe those take on a different role because of the network of connectivity. And so that's where that field-based inventory can be helpful. Heinsberg is a great example. The largest forest blocks in Heinsberg are considered priority at the statewide scale. But at the Heinsberg scale, they're absolutely highest priority. I'm talking about like the Heinsberg Town Forest, the Bissonnet property. Absolutely important. And so there's a bit of a difference between a statewide prioritization and the town prioritization. And so that's why towns like Jericho and Cornwall have engaged in local inventory and are now marrying that data with this big statewide prioritization to determine, well, what are the next steps for our town?
Very interesting. Great. Well, thank you very much. Any other questions from those of you on? Go ahead and type them in. We'll give you another second to do that in case we've sparked any questions. If not, we'll give it a second or two. Jens, do you have anything else you want to add or share?
It's such a pleasure to be with you all today, and I'm happy to continue to help you understand the conservation design and BioFinder. I've worked with several of the towns that are represented here today, and I really focus at that municipal level, but I'm absolutely happy to work with conservation commissions and other commissions in town to help you understand what the science is. Thank you all so much.
That's great. Well, I don't see any more questions, so thank you all for joining us. With Coverts, we're working to see a resilient, connected forests for wildlife, for movement, which is everything that Jens just talked about. And as private landowners and conservation commission members, you have a key part in playing how those connections are made. And we want to thank you for helping to make those connections and are here to help you as you look to steward your land. Thank you very much, and everybody have a great day.